Good morning students. I am Nagamani Naidupeta. Today we are going to learn about the chemical properties of 15th group elements. We have already learned about the physical properties and the electronic configurations of the 15th group elements. Now we are going to learn about 15th group chemical properties of 15th group elements. So before going to knowing about the chemical properties, we shall know about the electronic configurations and the oxidation states of the 15th group elements. Oxidation state is depend on the electronic configuration. So the general electronic configuration of 15th group elements, it is ns2 np3. So s orbital is half filled and p orbital is the s orbital is completely filled, whereas p orbital it is half filled. So it is a stable electronic configuration. Stable electronic configuration. So that is about the electronic configuration of the 15th group elements. So next one, what are the oxidation states of the 15th group elements? First of all, we will discuss the element wise nitrogen. It shows -3 oxidation state. General oxidation state is -3. Why? Because -3. When 15th group elements receives 3 electrons, they will go to the ns2 np6 configuration. And ns2 np6 configuration, that is the nearest inert gas configuration. So they will readily show the -3 oxidation state. Nitrogen always shows -3 oxidation states because of its high electronegativity. The electronegativity value of nitrogen is also 3.0. And whereas next one is the phosphorus. It exhibits -3, +3 and then +5. In some cases phosphorus will also exhibit +4 oxidation state also. And next one is the arsenic. It will shows +3 and then +5. Antimony, it will also show the +3 and +5, whereas bismuth it shows only +3 but not the +5. Why bismuth does not show +5 oxidation state? We will go to the configuration. The electronic configuration of bismuth, it is 6s. Outermost electronic configuration is 6s2 6p3, whereas 2 electrons are present in the 6s orbitals, paired electrons. These paired electrons are reluctant to participate in the chemical bonding. They are reluctant to participate in the chemical bonding. This effect is called as the inert pair effect. Inert pair effect. So due to this inert pair effect, bismuth shows only +3 oxidation state but not the +5 oxidation state. So in the +5 oxidation state of bismuth compound is only one compound, that is bismuth pentafluoride, BaF5. It only gives the +5 oxidation states. So that is about the oxidation states of the 15th group elements. From these oxidation states, we will conclude that nitrogen shows -3 oxidation state, whereas phosphorus, arsenic and antimony, they will show 2 types of oxidation states, that is +3 and then +5, whereas bismuth it shows only +3 oxidation states. How? Phosphorus, arsenic and antimony, they will show +3 and +5 2 types of oxidation states. We will go to the electronic configuration. So phosphorus, arsenic and antimony, they are having the empty d orbitals in their outermost orbit. So the electrons present in the nearest paired electrons, s electrons, they will split into the unpaired electrons and they will go to the nearest d orbital. So the oxidation number will increase. We will discuss this by using phosphorus atom. The electronic configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. So here it is a 3d orbital, it is empty orbital. So we can write the electronic configuration, outermost configuration, by using box diagram. 3s2, 3p3 and then 3d, 2, 3, 0. In first excited state, when the higher energy is given to the phosphorus atom, it will go to the excited state. The paired electrons which are present in the 3s orbital, they will dissociate into single electrons and they will occupy the 3d orbital. They will occupy one of the 3d orbital. So here we have 5 unpaired electrons, one s electron, 3 p electrons and 1 d electron. So it will show the +5 oxidation state. Similarly, arsenic and antimony will also show same type of +5 oxidation state. That is about the oxidation states of the elements. And the next one is the chemical properties. Chemical properties. Chemical properties means how they react with the other elements. That is about the chemical properties. First one is reaction with hydrogen. In chemical properties, we have similar chemical properties for all group elements. That is, first one is reaction with hydrogen, and second one is the reaction with oxygen, and third one reaction with the halogens, and fourth one it is reaction with the metals. These are the general characteristics and general chemical properties of all elements, group elements which are present in each and every group. So first one is reaction with hydrogen. When any of the element react with hydrogen, the compound is called as hydride. Compound is called as the hydride. Here the 15th group elements reacts with hydrogen to give MH3 formula containing compounds, hydrides. So the general formula of the hydrides, it is MH3. M may be, what is M? M may be, it may be nitrogen or phosphorus or arsenic or antimony or the bismuth, any of the element. That is about the M. So next one, the stability of hydrides. Hydrides of these 15th group elements are ammonia. First hydride is NH3. It is called as ammonia. It is more stable than the PH3. More stable than PH3, that is called as phosphine. It is more stable than the arsine, ASH3. This one is also more stable than the antimony hydride, that is SbH3. It is greater than BiH3. So highest stable hydride is ammonia and least stable hydride is the BiH3. That means the basic nature increases. Now, ammonia is most basic, whereas BiH3 it is least basic. Why it is least basic? Because of it's unstable. It readily gives the hydrogen. BiH3 gives rise to Bi3 plus 3H plus. So any H plus ions giving compound is called as acid. So the basic nature gradually decreases from ammonia to bismuthine. Ammonia to the bismuthine. That is about the hydrides. Why the stability will also decreases? Why the stability of hydrides from ammonia to bismuthine decreases? That means the bond enthalpy between the nitrogen and hydrogen or the 15th group element and the hydrogen, the bond enthalpy decreases. As the bond enthalpy decreases, dissociation will readily occurs as well as the stability decreases. That is about the hydrides of the 15th group elements. All of the hydrides are in gases. These all hydrides are the gases, whereas ammonia, it can condense to the liquid also. Ammonia can be condensed to the liquid also. Why? Because due to the intermolecular hydrogen bonding in between the nitrogen and hydrogen atoms, ammonia gets easily converted as a liquid. Remaining or they do not convert as the liquids. And next one is the bond angles in hydrides. So first one is ammonia. In ammonia, the bond angle is already we have known, that is 107 degrees 28 minutes. Whereas in other elements, that is PH3, ASH3, SbH3 and then BiH3, these bond angles are nearly 90 degrees. Why? Because in ammonia, s orbital, 2s orbital and 2p orbitals, 3 orbitals get hybridized to give 4 sp3 hybridized orbitals. So these 4 sp3, due to the formation of 4 sp3 hybrid orbitals, its bond angle will be 107.28 minutes. sp3 hybridization, it is having the 109 degrees 28 minutes. Its bond angle will be 109.28 minutes. Whereas due to the repulsive force in between the bond pair and lone pair, ammonia has the bond angle changed to 107.28 minutes. Whereas phosphorus, arsenic and antimony and then bismuthine, these have the nearly 90 degrees bond angle because there is no hybridization takes place. Pure p orbitals are directly involved in the bonding. So pure p orbitals, they have the 90 degrees angle in between the p orbitals, so they will directly involve in the bond formation but not the hybridization. So that is about the bond angles of the hydrides. The next one and next chemical reactions is reaction with oxygen. Any element reacts with oxygen, that compound is called as oxide. So here the 15th group elements will also react with oxygen to give their oxides. First one is the nitrogen. Nitrogen reacts with oxygen to give nitric oxide, nitrous oxide, nitrogen dioxide, dinitrogen tetroxide, and then dinitrogen pentoxide. So this N2O4 is also called as a nitrogen dioxide, NO2. So we have 5 types of oxides formed from when nitrogen and oxygen are combined. 5 types of oxides are formed. Here the oxidation number of nitrogen, it is +2, this is +1, this is +4, and this is the +5. So +1 to +4. Another oxide is also there, that is N2O3, dinitrogen trioxide or dinitrogen sesquioxide. Its oxidation number is +3. So nitrogen shows +1 to +5 oxidation states instead of -3 oxidation state. So it shows +1 to +5 oxidation states only in oxide compounds, only in the oxide compounds. Remaining compounds, it always exhibit only -3 oxidation state. And the next one, phosphorus. Phosphorus shows 2 types of oxides, phosphorus, arsenic, and then antimony. These are having the 2 types of oxides. Those are P2O3 trioxides and then phosphorus pentoxide, that is P2O5. Only 2 oxides will form by the phosphorus, arsenic, and antimony. So here oxidation state is +3 and here it is +5. As the oxidation number increases, acidic nature also increases. Oxidation number increases, acidic nature increases. And next one, when these oxides are dissolved in water, they will give oxoacids. Oxides of these elements, that is 15th group elements, plus water. When they dissolve in the water, they will give oxoacids. So these oxoacids are when nitrogen dioxide NO2 plus H2O gives rise to HNO3. That is nitric acid. So nitrogen oxides give 2 types of oxides, that is nitrous oxide nitrous acid HNO2 and nitric acid, that is HNO3. Whereas phosphorus gives different types of oxoacids, but two are the more important, that is phosphorus acid H3PO3 and second one is the phosphoric acid H3PO4. These two are the most important oxo acids of the phosphorus. Simultaneously, remaining arsenic and antimony, they will also give the +3 and +5 oxidation numbers having oxo acids. Next we will learn about the reaction between 15th group element and then halogens. So reactions with halogen. What are halogens? Halogens are fluorine, chlorine, bromine, iodine. These are the main halogens. When 15th group elements, they will react with the halogens. Nitrogen gives only NCl3 or NX3 containing halide. Nitrogen gives only NX3. X means halogen. X is the halogen. So the general formula of the halides, it is MX3. General formula of halides is the MX3. Nitrogen gives NX3, NF3, NCl3, NBr3 and Ni3. So that is about the nitrogen halides. Whereas phosphorus, arsenic, antimony, these will give the formula of containing MX3 and MX5, two types of halides. MX3 are called as the trihalides, whereas MX5 it is called as pentahalides. So two types of halides are formed by the combination of phosphorus, arsenic and antimony with the halogen atoms. And next, bismuth. We will come to the bismuth. Bismuth gives only trihalides, that is BiX3. Whereas when bismuth reacts with fluorine, it will give the pentahalide also. So the pentahalide of bismuth is only the fluoride, because fluorine is having the highest electronegativity. Due to the highest electronegativity of fluorine, it will absorb the electrons from bismuth, so it will give the bismuth pentafluoride. So that is about the halides. Why? Because here the phosphorus, arsenic and antimony, they will show both +3 and +5. In excited state they will show +5 oxidation state due to the electron shifting from s orbital to the d orbital. So that's why they will show the MX3 and MXY, two types of halides. Nitrogen gives only MX3 type halide but not MX5. Nitrogen does not give the MX5 halide. Why? Because it has no d orbital at all. Nitrogen is the smallest element and it has no d orbital in its outermost orbit. So it gives only MX3 halide but not the MX5. That is very much important in the 2 marks questions. Why nitrogen gives only MX3 type of halide but not MX5? Due to the absence of d orbital or the not present of d orbital, it gives only MX3 type of halide but not the MX5. And next one is the next one, halides and reactions with the metals. Reaction with metals. How 15th group elements react with metals? They will give 15th group elements react with metals to give binary compounds. To give a binary compounds. What are those binary compounds? For example, Ca3P2, calcium phosphide. Calcium phosphide. Mg3N2, magnesium nitride. And zinc phosphide, Zn3P2, zinc phosphide. And zinc stibinide, Zn3sp2, zinc stibinide. And then calcium arsenide, Ca3As2. So these are the main compounds given by the 15th group elements. These are all stable compounds. These are all the stable compounds. And next one, important one, that is anomalous behavior of nitrogen. Anomalous behavior of nitrogen. we learnt about the anomalous behavior of first element in each group. That is why, because it has the smallest size, small size. When it is having small size, it has highest electronegativity and highest IP value. Due to this small size, that first element is having highest IP value and then highest electronegativity value. So that is the most one of the reason for the anomalous behavior of nitrogen. And second one, nitrogen forms, it shows only -3 oxidation state but not the remaining oxidation states. So next one is the important one, is the nitrogen forms p-pi bonding with oxygen. p-pi bonding with the oxygen. d-pi bondings. p-pi d-pi bondings with the other elements. Only nitrogen shows p-pi bonding, whereas in the other compounds or the other elements present in 15th group, they will participate in the p-pi d-pi forming. And next one is the reluctance of nitrogen. Nitrogen is highly stable at room temperature, because nitrogen in the nitrogen molecule or molecular formula is N2. That means 2 nitrogen atoms combine to form a nitrogen molecule. So in between these 2 nitrogen atoms there is a triple bond. So this triple bond, the bond enthalpy to break this triple bond is 941.5 degrees kilojoules per mole. 5 kilojoules per mole. So it is the highest bond enthalpy or bond dissociation enthalpy. So it is reluctant at the room temperature. It does not participate easily in chemical reactions at room temperature. That is about the nitrogen anomalous behavior. That is about the chemical properties of this 15th group element.